Well, hi there. Let's take a look at finding the payment amount that we need on an annuity in order to achieve a certain investment goal. Delta Math already gave us a simplified formula for that. See how Delta Math just it's so useful? I think it ought to tell you to go and rearrange your own formulas. And you can rearrange your own formulas for practice, nothing's stopping you from doing that. But since Delta Math has been so kind as to do this, let's go ahead and use that in Desmos. So we just need to rearrange this just a little bit. And we just have actually it's not rearranged. We want to solve for D. We do need to rearrange our own formulas. So let's rearrange this formula. So what I'm going to do is take this and I'm going to cut it out and I'm going to do F divided by that. And then I'm going to remove that and bring it up there. So I have rearranged the formula for R. Okay, so now I can put in, I'm going to remove that there. And I want a slider for F. So let's go here, F equals. So now the future value multiplied by the interest is going to be, that's A. I used F for future value, but we could say A for amount. Whatever. A. Okay, cool. All right. And Ximena wants to end up with $177,000. Don't use commas in Desmos, doesn't like it. So that's how much she wants to end up with. We have an annual interest rate of 7.8%. So we're going to put that in there. 7.8% looks like that. And then we're going to do this for 13 years. So that should just about solve it for R. And let's move this over here so it looks like this. R equals there. So that's the regular payment that Ximena needs to make. Let's take a look at this situation and see if that sounds reasonable. The number we had was about 8,000, a little bit more than 8,000. So let's see. She's saving money and plans on making monthly contributions into earning an annual interest rate of this much compounded monthly. If you would like to end up with this much after 13 years, she's compounded monthly. I missed that bit, so I need to go in and change things. I need to actually calculate I and calculate N. N will be 13 times 12, which is 156. So I'm going to go in and change that. 13 times 12 is 156. Okay, so that's my new N. And my I is going to be the interest rate, which is 7.8 divided by 12. Let's figure out what that is. 7.8 divided by 12. 7.8 divided by 12 equals 0.65. 0.65% per month. So go ahead and throw that into here. 0.65. Now, this should have a very different output. Yes, it does. $658.34. So let's see. How much does she need to contribute to the account every month to the nearest dollar to have this much money after 13 years? And if you think about it, well, if you're contributing a little bit more than half of $1,000 every month, and you've got a halfway decent interest rate, it's pretty good. You're gonna get somewhere with your money, so you're gonna get that far. So that is the answer. 36358. Sorry, 658. Copy it in. 658. Enter. Hooray! Okay, so now let's do another one. New problem. Okay, Nevea, she's saving money, and she's going to make monthly contributions into an account earning monthly interest rate of this. So we're already given the monthly interest rate. It's that. So I'm just going to copy that and put it into Desmos. I can actually just do this and get my numbers. So I'm going to put that in for interest rate. That's a fraction of a percent, so it will go there after a 0.065. She wants $94,000. And she wants it within 10 years. Because we're working monthly here, N is the number of compounding periods. So that would be 120. There's 120 months in 10 years. So let's see, what do we get? $510.95. We need it to the nearest dollar, so it's $511. Submit. And that's how you would do this in Desmos using Desmos to conquer delta math. All right. Thank you very much, everyone. Any questions, hit me up by email. Otherwise, bye for now.